Okay, let's look at this question here. When you look at this question, they said suppose fx is equals to this piecewise function, right? This is a piecewise function. When x is less than equals 2, you follow this. When x is greater than 2, you follow that. They ask you identify any points of discontinuity. Identify any points of discontinuity. Determine giving reasons if they are removable. Okay? Infinitive and or jump discontinuity. So what we're gonna do is this. First thing first, we know that this function, look at here, this function, you can write like this. You can write it as what? X minus 1. This one you can write as what? X. Okay, we'll go this way. We don't need to go this way. Here. For this one, you can see, from this function here, you can see that when, for this one, only for this one, we can go by x equals 1, x equals -1. If x equals 1 or -1, that's the time make this one equals 1. And then 1, we will make x minus x fourth power minus 1 equals 0. And denominator equals 0, that's not what continues, right? So that's called D. So that means you have those 2 points discontinuity there. But what kind of discontinuity? You will see that, you see, for example, this is the 1 here, okay? If you go from left side approach to 1, if you use a negative side approach to 1, you will get what? This one will be what? Like a 0.9, okay? You think this way, 0.9. 0.9 minus this one would be negative. So this part will be what? The negative now. And this one also the negative. But this is a very small number though. So negative over negative positive. So that means what? At this point here, this graph will go to positive infinitive. But if you go this one here from the right side approach to the 1 here, right? This is like a 1.1, like this. 1.1 square, fourth power, bigger than 1. Minus 1, positive, but a very small number. And this is negative. So this one will be positive. So that means what? This one goes this way. Go negative infinitive. So at the x equals 1, x equals -1, similar case. For this one here, because x equals 1 and x equals -1 belongs to this interval. So the function which is infinitive discontinuity, okay? Now, there's another one. You look at here, alone, x equals 3. The other one is x equals 3, okay? That's also discontinuity. You know why? Here, imagine if we go this one, this is a 3, right? This is 3. So we're gonna go from the left side approach to 3. That would be like 2.9 like that, right? So let's look at what's this about, okay? I put it here. This one will be 2.9 minus 3 is -0.1. So absolute value is positive 0.1. This is 0.1. But the bottom one here is what? 2.9 is also this one. Oh, this is negative 0.1 like that. So that means this one will be the negative. Overall, this is negative, right? And will be -1. This one is -1. But if you go from this side approach to 3, that's 3.1 like that. So that this part will be equals what? 3.1 minus 3 is a positive 0.1. So that's 0.1 here. But the bottom one here is what? 3.1 is 0.1. That'll be 1. So that means from left side approach to infinitive, this one function goes to -1. For example, like this one. For example, like this one, right? Okay. This is y, this is the x. So on this side, the function is what? -1. And on the right side here, you got a +1 like this. So that belongs to what? Jump. See that? That belongs to jump. So that means okay, this part we said already. That's what? Infinity. Okay? Discontinuity. This one belongs to jump. Right? And be careful there. There's another one. That's at the 2 there, because this is where the joints of the 2 piecewise function. So when you have the joints of piecewise function, you gotta check on that part. So when you have that one, you can see that this is 2, right? This is 2. If the x value approaches 2 from left side, for example, that would be like 1.9, okay? So this one will be what? That belongs to this interval, less than 2. So that means this one is the top here is 1.9 minus 1 over is 1.9 fourth power minus 1. Of course, this is negative. This is negative. This one equals what? Negative 0.1. But this is positive there, right? Right? And but if you from the right side approach this one, for example, like 2.1. So if you go there, right side, you got to use this now. Instead of using the first one, you got to use the second one now. So that's the time you have what? 2.1 minus 3 absolute value over 2.1 minus 3 like this, right? So this one will be positive. This is positive. So this one will be what? Positive like at 0.9. This one will be what? Negative 0.1. But be careful. This value, if you do the calculation, they're not the same. They're not equal. So that means we have what? Jump there, right? So it means the left limit and the right limit. For this whole function, use 2 pieces, you'll find there is a jump there. So that's why x, I put it here, okay? X equals to 2 there. That also belongs to jump. So let's recall what we have here. If you want to determine how's the function, where's the discontinuity, you simply pick up the points at the jump, at the joints here. That's why we're the 2 and then from. And then you check on the limits from left side and right side. You can see if both sides, the limits, they're not the same. Like this case here, that belongs to jump. And also the other discontinuity, you can see the clues from what? From the denominator, because it's a fraction, from the denominator there. So x equals -3 here. So make x -3 equals 0. So x equals 3. That's another discontinuity. And also you study about on both sides of the limits, if they're equal or jump or infinity. Okay? So you can see that this also belongs to the jump. And for this one here, will be what? Will be from here, the denominator here, they have a denominator here. You make this one equals 0, you have x equals 1, x equals -1. And that part will be what? You can see both sides. In the left side approach to limits go to the positive infinitive, right side goes to negative infinitive. So that means what? They have an infinite discontinuity. Okay? So if you have any questions, please let me know. Thank you. Bye-bye.